Imagine a shadow, moving through the cosmos. It is not a shadow cast by an object blocking the light. This is a shadow that consumes light itself. It is a perfect sphere of absolute blackness, a void gliding silently through the interstellar medium. At first, it is invisible to our telescopes, a ghost in the vast, star-dusted dark. Our first clue would not be its presence, but its effect on the things around it. The light from distant stars, galaxies that have shone for billions of years, begins to warp and bend. Their ancient light is forced onto new, distorted paths, creating strange, luminous arcs and rings, a phenomenon we call gravitational lensing. This is the calling card of an approaching black hole. This object is not merely a celestial body. It is a fundamental distortion in the fabric of space-time. It represents gravity in its most extreme and terrifying form. Here is a force so powerful that the universe's most fundamental speed limit, the speed of light, is insufficient to escape its grasp. The very laws of physics as we know them are pushed to their breaking point and beyond. To understand what awaits our planet, we must first grasp the core concepts that define a black hole. Think of space-time as a flat, stretched rubber sheet. A massive object creates a small dimple, like a star or a planet. A black hole is not a dimple. It is a puncture, a well of effectively infinite depth from which nothing can climb out. The edge of this bottomless well is a precise, invisible boundary known as the event horizon. This is not a surface you can touch. It is a one-way door in space-time. Once you cross this threshold, the path forward leads only in one direction, inward. Escape becomes a logical impossibility. At the very heart lies the singularity, where all the mass is crushed into zero volume and infinite density, where physics, including general relativity, breaks down. For our doomed Earth, the singularity represents the final destination, the point where its matter is compressed beyond all recognition. The force responsible isn't simple gravity, but the difference in gravity across the planet. Tidal forces. Pull both ends equally, and it moves. Pull one end harder, and it stretches. A black hole tugs far harder on Earth's near side than its far side. These monstrous tidal forces can tear apart entire stars and planets. Size matters. A smaller stellar mass black hole has extreme gradients. A supermassive one's gradients are gentler over the same distance. One could theoretically cross a supermassive horizon without immediate shredding, but a stellar mass encounter would spaghettify Earth long before the event horizon. The destruction would begin far out in space, a countdown written in the language of gravity. The term for this cosmic stretching is delightfully and frighteningly descriptive: spaghettification. It is the process by which an object is elongated vertically and compressed horizontally, like dough stretched into a strand of spaghetti. The gravitational gradient is the relentless chef in this cosmic kitchen. The side closer to the black hole is pulled exponentially harder than the far side. This immense differential initiates catastrophic unraveling, be it a star, a planet, or anything in between. As Earth is drawn closer, every atom is tugged. Continents stretch, the molten iron core stretches, the very ground beneath our feet stretches. Our spherical world bulges and elongates into a prolate spheroid. The pull is uneven, as front and back are pulled apart. The equator compresses inward. Imagine squeezing a tube of toothpaste from the middle. The paste shoots out the ends. Similarly, the planet's matter is funneled into a long, thin stream, rock, water, and air, accelerating toward the horizon. The cohesive planet ceases to exist, transformed into a flowing river of incandescent plasma. Any structures or life are doomed early. Earthquakes, planet-wide volcanism, the crust tears, the atmosphere is stripped, the oceans boil and siphon into space. Spaghettification is not something you can watch from a safe place. It is the complete dissolution of the surface and everything below it. The end would not arrive in an instant. It would be a gradual, escalating symphony of destruction, with a clear timeline of events. Long before close approach, gravity upsets the solar system's balance. The first victim could be the moon, flung away, or sent on a collision course. The placid rhythm of tides would be the first casualty, swelling to monstrous heights. Mega tsunamis would scour coastlines, racing hundreds of miles inland. As the black hole draws nearer, the atmosphere is next. Tidal forces stretch the very air we breathe. Winds of unimaginable speed would roar, far beyond any hurricane. The accretion disk would dominate the sky, blasting lethal X-rays and gamma rays. The surface would be sterilized as auroral curtains blaze overhead. Day and night would lose meaning, replaced by an ominous twilight. The solid Earth would begin to fail, its crust behaving like a fragile eggshell. Continuous planet-wide earthquakes rip great fissures as molten rock vents from the mantle. Mountains crumble, continents warp and flow. Friction liquefies vast sections of crust and mantle. The ground turns fluid and treacherous. Finally, Earth loses physical integrity. Chunks, even continents, are ripped free, joining the growing stream toward the black hole. The oceans boil away. Superheated vapor joins. The stripped, glowing core is yanked outward. What remains is a river of our own parts, glowing red-hot as it spirals into oblivion. The transformation from a vibrant, living world to a stream of fundamental particles is the ultimate act of deconstruction. As tidal forces exceed the strength of rock and metal, spaghettification accelerates into its final, violent phase. The planet is no longer just stretched, it is unmade, chaotic, yet orderly, as every piece is sorted by its proximity to the whole. The atmosphere and oceans, the most mobile, are stripped first, forming a tenuous halo at the vanguard of our planet's demise. Heavier crust and mantle follow, pulverized rock, molten silicates, vaporized minerals, an incandescent filament stretching for hundreds of thousands of miles. This stream would not be dark. Friction and compression raise temperatures to millions of degrees. A brilliant ribbon, brighter than any star in our sky. Owing to Earth's orbital momentum, the filament joins the accretion disk, a swirling vortex where our remains mingle with dust of dead stars and ruined worlds. Over millennia, the disk spirals inward, emitting intense X-rays. The very atoms of mountains, oceans, and ourselves become fuel, adding a tiny fraction to the black hole's mass and spin. Faced with apocalypse, we ask, could we hide? Could we run? The answer, grounded in physics, is no. Bunkers withstand blasts and quakes, assuming a stable planet. Spaghettification attacks the planet itself. A bunker stretches and crushes with the rock. It's like trying to survive a blender by hiding inside an ice cube. Escape requires warning and velocity. Closer to the hole, the required energy soars exponentially. Long before tides become unsurvivable, escape velocity exceeds any conceivable technology. The environment is lethal, a maelstrom of high-energy radiation, warped space-time, and dense infalling debris. Any escape must begin centuries, even millennia, in advance, when it's still light years away. We think on planetary scales. A black hole operates on cosmic scales, its influence extending for light years, dismantling entire stars. No shield to build, no engine powerful enough, no hiding place deep enough. The story of Earth and a black hole is not a battle to be won. It is a surrender to a fundamental force of nature. One of the most bizarre consequences of general relativity is its effect on the flow of time. Near a black hole, gravity is so intense that it literally slows time relative to a distant observer, gravitational time dilation. From far away, as Earth nears the horizon, its fall seems to slow. Its light shifts from white to orange to red and into the infrared. To the outside view, Earth never truly crosses. It freezes at the edge, dimming forever. But for the matter that once was Earth, for any falling observer, time feels normal as catastrophic forces unfold. Your own clock ticks on as you are stretched, heated, and crushed. In a stellar mass hole, horizon to singularity can pass in a fraction of a second. The slowing is a relativistic difference between frames. It does not alter the physical reality for the falling object. The universe would seem to speed up, a fleeting glimpse of deep time, before your own timeline ends absolutely at the singularity. The illusion of a gentle fading is just that, an illusion. The reality is a swift and violent conclusion. The moment the first atom crosses the event horizon marks a profound, irreversible transition. Space-time is so warped that all possible futures lead inward. Before this, escape was physically impossible. After this, it is logically and geometrically impossible. Within the horizon, space and time interchange roles. Moving away from the singularity becomes as impossible as traveling back in time. The leading edge crosses, while the trailing edge lags hundreds of thousands of miles behind. No signal, no light, no information crosses back. The planet is severed from the universe. Inside, tides stretch and compress the plasma, heating it further. All structure, information, and history are obliterated into a quark-gluon soup. The singularity, the end of the line, takes Earth's substance into silence. The black hole grows by an infinitesimal amount. As a distinct entity, Earth is gone. The story of Earth's fall into a black hole is a dark and terrifying thought experiment, absolute, final destruction. Yet it is also a lesson in scale and humility. Our vast, stable world is, in truth, a fragile speck in an astonishingly powerful universe. Gravity, weakest on small scales, is the undisputed master on cosmic scales, building stars and galaxies, and in black holes, unmaking them. Black holes are not aberrations but recyclers, reducing matter to fundamentals, powering the cosmos's impersonal engine. The odds of a rogue black hole encounter are infinitesimal. This knowledge renders every sunrise, every tide, every living creature more precious. That we can ponder and understand such things is its own miracle. Wonder pushes our science and imagination to their limits. By looking into the abyss, we learn about the light. We are small, yet part of the grand, interconnected cosmic web. Our smallness does not make us insignificant. It makes our brief, improbable existence all the more extraordinary. And that is just one of the countless mysteries hidden in the vast darkness of space. If you're ready to explore a new corner of the universe with me every single week, make sure to subscribe and hit the notification bell so you never miss a launch. Until next week, keep looking at the stars.